If a number n cannot be expressed as the sum of two odd composites, then if we subtract every possible odd composite, then all of those differences will be either prime or 1. So let's make a table of the sum of odd composites and primes. Here are our smallest odd composites. We'll put in the sums here in the middle. Let's take, for example, 20. If we subtract all of the odd composites that are less than or equal to 20, 15, and 9, we get two prime numbers. So 20 cannot be expressed as the sum of two odd composites. This is also true of 22. Subtracting the only odd composites that are less than or equal to 22, 9, and 15, both times we get primes. Another example is 26. Subtracting 21, 15, and 9 always yields a prime number. If we check 30 though, when we subtract 21 from 30, we don't get a prime number. So 30 does not satisfy the problem. But we do have 32, and then we see that 32 appears in every single row corresponding to every single odd composite. 34 does not appear in this last row, so it doesn't satisfy. 36 does not appear in the second to last row, but 38 does. We'll check some of these higher numbers. Here's 40, but we don't have 40 in this row that's third from the bottom, so it doesn't satisfy. 42 doesn't appear in the last two rows. We have a 44 here, 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 but not in this first row. So it's looking like that our largest even number that can't be expressed as the sum of two odd composites is 38. And if we're running out of time, we can put that as our answer. If we have more time, we can prove that this is in fact the largest even number. In our proof, we will note that every even number, n, has 3 mod 6 residuals, 0, 2, or 4. We'll also note that we can write an odd composite number as the product of 3 and 3 plus 2k, where k is a non-negative integer. The second factor is odd, and multiplying it by 3 makes it composite. So we are going to write our number n as the sum of 9 plus 6k and another odd composite, and take the mod 6 residual. So for example, we'll write n as the sum of 9 plus 6k and 9. In mod 6, this is 0. So for all of the multiples of 6 that are greater than or equal to 18, we will have that n is the sum of two odd composites. We'll do the same thing where n is the sum of 9 plus 6k and another odd composite. We'll try 15. This is also 0 in mod 6, so it doesn't add any information. Let's try 21. Also 0 in mod 6. So we'll try the next one, 25. In mod 6, this is 4. So all of the even numbers that leave a remainder of 4 when divided by 6 and are greater than or equal to 34, we can write that number as the sum of two odd composites. We'll keep going. Adding 27 is also 0 in mod 6. Adding 33 gives us 0. So let's add 35 and see if that takes care of the last mod 6 residual. And there it is, 2 in mod 6. So all of these numbers that are greater than or equal to 44 are also going to be the sum of two odd composites. We've already got n equals 38. That can't be written as the sum of two odd composites. Trying the next few even numbers against these tests, if n is equal to 40, which is 4 in mod 6, that's taken care of by the second case here. N is equal to 42 is 0 in mod 6, and we've got that taken care of here for n greater than or equal to 18. And when n is equal to 44, all of these other mod 2 residuals greater than or equal to 44 are also going to be written as the sum of two composites. Therefore, we know for sure that our maximum value is 38. If you'd like me to solve any other math contest problems, please leave them in the comments.